We like scripts also because they may accept arguments. Running script with different arguments, we can cause that the same script will execute a bit different actions. So let's see how the scripts accept arguments. Every script, when started, gets a set of information related to the way how the user called the script. Some of those variables are $0. It holds information about the path to the script itself. The name of this script is argsh, so we may expect that the $0 will contain argsh. Apart from the script name in $0, we have also a set of variables pointing to the value of the other arguments passed to the script. $1 is the first one, $2 is the second, $3 is the third, and so on. But the 10th argument will behave a bit differently, so we will display it as well. Note that already here the 1 is displayed in red, while the 0 is white, but we will see the real problem when the script will be started. There are also a few special variables. Yes, those strange variables that after the dollar sign have a symbol. $hash allows to get information about number of arguments. $@ allows to access variables using a list. $* allows to access variables using one long string with all the values. Let's see what the script will display when we start it passing some arguments. The arguments are A, B. The third argument will be double letter C with space and the next letters of alphabet. So what are the values? $0, argsh. Indeed, that's the script name with a path to it. We used here relative path, so the variable contains also a short path to the file. Next, the parameter 1, that's A. The parameter 2 is B, and parameter 3 is doubled C. That's all good. But the argument number 10 is incorrect. The script did not understood the argument 10. It understood it as $1 and 0. $1 was replaced with A, so finally we have A0. That's incorrect, and we will repair it in a moment. $hash is 10. Indeed, we have 10 arguments, so that's okay. The next two variables, at first look, seem to be the same. Soon we will see that's not true. I will come back to the script, and first of all I will correct the argument number 10. The value 10 should be enclosed in curly brackets. That notation may be also useful when you need to get the value of the variable and put immediately after it another text. It may happen that this additional text will be understood as continuation of the variable name, resulting in incorrect results. In such case, just put the variable name into curly brackets and all will work okay. That's already something what we can check starting the script again. Indeed, the argument number 10 is now J. That's good. It's a time to take closer look into $@ and $*. Currently we may have impression that they have the same value. To see the difference, I will write a for statement. The variable param will take a value from the $@. And note, I'm using here quotes. That's our defense against parameters that could contain spaces in the value. So what's the result of execution of the script? We can see a list of arguments displayed one after another, and indeed the parameter number 3 containing letters C separated by space is treated as one argument. That's good. So let's make another test. I will replace @ with asterisk. Now the list displayed again, but it's just a long string. I will not say that's bad. It's just something else created by design. When you want to have separated arguments in the form of a list, use $@. But if for any reason you want to have a long text of all the variables, use $*. Note also that if I would remove the quotes, then $* will be treated differently. Now that's something like a space-separated list of values. Note that currently the third argument, containing two letters C separated by space, is treated as the separate values. That's something what could cause programmatic errors, so please be aware of that. To complete the examples, we can also analyze the result of using $@ without quotes. What's the result? Again, the double C are treated as two separate values. I would say that's incorrect, so watch out such errors. The quotes will protect from such trouble. From time to time, in the scripts you may also find the command shift. We can think of the list of arguments like a queue. $1 is the first, $2 is the second, $3 is the third, and so on. Shift will cause that the first argument will be removed from the queue and all the other arguments will move forward. That means that $2 becomes $1, $3 becomes $2, $4 becomes $3, and so on. The command shift shifts the arguments. Let's see shift in the action. The loop may seem to be a bit crazy, while $# is greater than 0. But wait a moment. $# is the number of arguments passed to the script. If the user would call the script, sending at least one argument, the loop could execute forever. Well, that could be true if the arguments would never be removed, but we know that shift removes the arguments from the queue, so maybe it will not be so bad. Now, in the loop, I will display only the value of the argument 1. Again, someone could say, that will not work. If we have multiple arguments, then displaying only the first one could be wrong. But again, if we move the arguments, then the $1 will change its value with each loop execution. That's all. Now we can start the script passing a few parameters. Look, all seems to work correctly. With each loop, the value $# was decreased by 1, what caused that the loop finally ended. And at the end, $# got the value of 0. Also, the $1 changed every time when the shift was executed. As a result, we were able to display all the parameters. We can observe it in a more detail in the bash debug mode. To run a script in debug mode, add bash-x before the name of the script. Now every command executed in the script is displayed on the screen. The first command checked if 6 is greater than 0. But what is the 6? 6 is the value of $#. Next, we displayed A, but what is A? It's $1, the first argument. Next, we executed shift. As a result, $# has now value 5, and the $1 argument is replaced by $2, $2 by $3, and so on. So now in the next line we see test if 5 is greater than 0. Why 5? Because it is the current value of the $#. Next we displayed B, but what is B? It's the current $1. Now again shift was executed. $# is now 4 and $1 got the value C space C. The process continues and at the end $# is 1, $1 got the value F and we executed the last shift. After that $# was 0, so the loop finished. If we call such a script without any arguments, it will also work correctly. In such case, the loop will not be executed at all, because $# is now 0 from the beginning. In this lesson, we have seen how to pass arguments to the script. Let's sum up all the information once again. The arguments are named $1, $2, $3, and so on. If you want to use $10 or greater, you need to enclose the number in the curly brackets. $0 points to the name of the started script. $# contains information about number of arguments passed to the script. $@ allows to use the arguments like array, $* treats the arguments as a long string of text separated by spaces. To process all the arguments, you can iterate over the list, but note that the $@ should be enclosed in quotes. Another option of processing all the arguments is to always use the argument $1 and move the arguments with the command Shift. The next lessons will show other methods of processing arguments.